Hello, my name is Madeleine John, and I am an IJP student studying microbiology and French. I spent the last year studying abroad in Bordeaux, France, where I earned a third degree in life sciences from the University of Bordeaux. I will be graduating this December and then beginning a master's program in cancer sciences at Queen Mary University of London under the Barts Cancer Institute. So I'm very excited to be going abroad again. Now, at the IGB Summit, I will be presenting what I did for my internship, which is the migration of glioblastoma stem cells in a 3D environment. So, glioblastoma is an extremely aggressive and lethal form of cancer. It is characterized by rapid growth, diffuse invasion, and an extremely low survival rate. It is the most common malignant primary brain tumor, and it is even known as the emperor of all cancers because of how difficult it is to treat. According to the Glioblastoma Foundation, the median survival for glioblastoma prognosis is just 1 year after diagnosis, and only 5% of glioblastoma cancer patients survive 5 years after diagnosis. So, what makes glioblastoma so difficult to treat? Why is this the emperor of all cancers? One of the main challenges is diffuse invasion, which is where the tumor spreads out all over the brain, infiltrating the surrounding tissues. So, due to this highly migratory nature of these cancer cells, they are able to escape treatment attempts such as surgical resection, chemotherapy, and radiation therapy. So, understanding their migration patterns could help us combat them. So, then how do they migrate? The extracellular matrix. This is a large and very intricate network of proteins and other molecules that surround and support the cells and tissues in your body. It is very dynamic and can even control the most fundamental behaviors and characteristics of cells, such as proliferation, migration, apoptosis, which is cell death, and it even helps cells communicate with each other and can be involved in repairing damaged tissue and other cellular functions. So now what's interesting with glioblastoma is these cancer cells actually remodel or change the extracellular matrix. Its ability to migrate all over the brain is largely due to these interactions with the extracellular matrix, and it remodels it for its own benefit so that it may continue to grow and migrate everywhere. So now this is where the topic of my internship comes in. We wanted to explore the influence of a novel 3D matrix on glioblastoma stem cell migration. So essentially, this 3D matrix, here's a picture of it here. It's almost a replication of the extracellular matrix in a way, but we can control it. So we're able to control how rigid it is, the coding, or which molecules or proteins we want to code our matrix with, and the physical pressure it has on cell migration. Now, the main goal of creating this 3D matrix was to see if it could actually be more favorable to the cancer cells. As in, will the cancer cells instead migrate towards this potentially more favorable environment instead of migrating around the brain? So, if you're curious to hear if this novel 3D matrix was able to influence the migration of glioblastoma stem cells, come see me at the IGP Summit. See you soon.